Hello students, welcome all. So we are going to discuss the Re-NEET test paper for physics, right? So today it got over. So let us discuss. People are giving different feedbacks that it was difficult paper and somebody is telling it is moderate to difficult, right? So we'll see this paper one by one. We'll go through these questions and let's see what are the type of questions they have asked and the level of difficulties and uh, whether it is lengthy or not or calculations is complex. Let us see that, right? Let's start. So question number one, a photon and an electron each of energy, the energies are given, right? Move in free space, they are moving in vacuum. The ratio of linear momentum of this electron to photon, so they are asking the ratio of the linear momentum and they have given the energy they have given, right? Energy means kinetic energy, of course, right? We can take that. So can be applied and some of these values they have given. Energy is given in electron volt. So let us see what calculations are involved. So if I write lambda is equal to h upon p, right? And they are asking ratio of linear momentum. So can we use linear momentum from here? So if you see electron is a particle, right? Electron is a particle, right? And if you take photon is not a particle. So for photon, definitely we'll use de Broglie wavelength, right? De Broglie wavelength we will use, right? So they are asking this ratio. So for electron, how do you calculate momentum? So suppose if you say that energy means we are taking kinetic energy. Kinetic energy is p square by 2m, right? So using this, I will calculate the momentum of electron because electron is particle. So from here, if I calculate the momentum of electron, it comes root 2 times of kinetic energy, right? And kinetic energy can be written as charge into voltage. So root under 2 times mass into charge into voltage. This capital V is the accelerating voltage, right? And this E into V, that is nothing but 20 electron volt. So this E into V directly it is given. You can say that energy is directly given as 20. You can directly substitute that, right? So this is kinetic energy they have given. You can directly substitute that. If they have given accelerating voltage, you can use it. So anyway, here you will use this equation, right? Kinetic energy is already given for electron. And what about for photon? Photon you have to calculate using this, right? Lambda you need to calculate. So for this, if you take for photon, momentum for photon, you'll have to use h upon lambda, correct? Now lambda is given. What are the things they have given? They have given again energy of that photon. So you can multiply frequency, right? So this becomes energy by speed. Speed, if it is going in vacuum, we can take a speed of light, correct? Speed of light E by c. So now we can apply this ratio. We have this information. So let us take this ratio Pe by P of the photon. Now we need to take root under 2 times mass into kinetic energy divided by E by C. Correct. This calculation only we need to do. And here this energy what they have given, energy they have already given 20 electron volt. So we need to substitute, this is in electron volt, we have to do some calculations here, right? The values they have given, can we quickly do some calculation or is there some approximation that we have to do? Let's try first calculation. So root under 2 times, see this kinetic energy and this energy they are same, right? So what I will do that I will take this inside, C will anyway get multiplied here, right? So what I will do is I am going to take it like this. So 2m by this I will get, so it will come as energy or kinetic energy because E and kinetic energy are same. Now let us substitute this. So C is 3 into 10 to the power 8, that we know. Root under 2 times mass Mass of electron, will use this 9 into 10 to the power minus 31, right? And energy, charge and other things we don't have to use it, right? Charge and other things we don't have to use it, because here this energy which they have given us 20, I think we have to use electron into volt. It is, we have to convert. So 20 electron volt means that we have to use that value, we have to use 1.6 into 10 to the power minus 19. So something, some simplification definitely will happen. Now you check out. So 3 into 10 to the power 8. This root calculation we have to check, right? So if I take this 10, this 10, 10 will get cancelled, 2, 2 also will get cancelled. So 9 by 16 means this will come 3 by 4. 3 by 4 definitely will come. And here if you take plus 19, so minus 31 plus 19 is how much? Calculate that. 10 to the power, then it will come. Check out this. So 19. Subtract that. So 2 will definitely come. I think it is 12, right? 12 it is, correct? 12 it is. And then root of that will give 6, correct? Minus 12 it will come, so minus 6 will come. Now check out this. So this is coming as 9 by 4 into 100. That means 900. 900 by 4 it is coming. Check out this, whether it is correct. 900 by 4. 900 by 4 is how much? Check out. Half of 900, half of 900 is 450. Half of 450 is how much? Check this. Half of 450, 225, I think. Yes, that's the correct answer. I think calculation is not difficult, easy calculation only, right? Let us move to the next question. Water flows in a streamline motion through a horizontal pipe of circular cross section as shown in the figure. Pressure difference of water between P and Q. So the cross sections are different and it's a circular cross section, and they are saying that pressure difference is given. Area of cross sections are also given. Rate of flow. Rate of flow of water means volume flow rate in centimeter cube per second. That means the discharge we have to calculate. So let us use that direct formulas we can try to think of using. What is the formula for that? Means it's a horizontal tube, right? Only cross section area changing. So we can see the pressure difference. Let us say here the pressure, definitely where the pressure will be, here pressure is more, here pressure is flowing like this, right? Anyway, let us write pressure difference. Pressure difference is half rho V2 square minus V1 square, or V1 square minus V2 square. So that's the pressure difference. We'll simply use this formula, that's all. So pressure difference they have given. What is the pressure difference here? What is the pressure difference here? Pressure difference they have given 15. Everything unit is in SI unit, right? Half density water it is, so we take is 1000. V2 square minus V1 square. Now note that here pressure is, here pressure will be high, fluid is happening like this. Here pressure will be high, right? So what happens when area decreases? According to equation of continuity, A into V, remember this Q is equal to A into V. Discharge flow rate remains constant. So this area, if area is large, velocity will be small, right? So here velocity will be small, here velocity will be large, definitely. So we are taking final velocity minus initial velocity. But anyway, velocity can be written as Q by A, right? So this you can write as Q square by A square, right? A2 square minus Q square by A1 square. So from here just we will calculate that, okay? And note that definitely A2 is smaller area, A1 is larger area. So take out this. So 15 into 2, let us make it multiply this side, so it will become 30. 30 divided by 1000, right? And this is the Q square you take out. 1 by area square you do. Area they have given 40, right? Area they have given 40. So let's take this as 40 and that is 20. So 1 by 20 1 by 20 square minus 1 by 40 square. But note that here we are taking everything in SI units. So this area we have to keep in meter, right? So it is centimeter square. So centimeter square means 10 to the power minus 4, right? Right, 10 to the power minus 4 we have to multiply. So in the denominator there will be a factor of 10 to the power minus 4, because we have to convert this centimeter square into meter square, right? So it will go this side, correct? It will go this side. So how much it will become? It will become 3, and this is 10 to the power minus 3, 10 to the power minus 6 will come, okay? That will become q square. Here you calculate, take LCM, calculate. If you want 20 square, you can take out. So 20 square I have taken out, common. So what is left here? If you want, you take one step. 20 square I have taken out. This is 1 minus. Here 20 square I have taken 20 into 2. So 1 by 4 will be remaining here. So this is 3 into 10 to the power minus 6 is q square by 20 square into, this has become 3 by 4, correct? 3 by 4. So from here what can we calculate? What can we conclude? This 3 will go away, right? So q square will become what? Q square will become, this is 20 square into 4. So 20 into 2 you can take, 40 square you can take. So this is 40 square into 10 to the power minus 6. So now q will be coming as 40, and square root means 10 to the power minus 3 will come, correct? This will come, but this discharge rate is what in terms of meter cube it is. It is in SI unit everything, right? It is meter cube per second. So meter cube we need to convert into centimeter. So 1 meter is how much? 1 meter is 100 centimeters. So 1 meter cube it is. So 1 meter cube we have to convert into centimeters. So 10 to the power 6 we have to multiply, because 1 meter is 100, 10 to the power 2 cube we are doing, right? So how much it will become? Check out. So this is 7. So how much it is? 4 factor will remain definitely. So here will be 5, sorry, 7 minus 10 to the power 4 will be, check out this, 10 to the power 4 it is coming. Did I do anywhere mistake in the calculations unit wise? Just check. So this is 15 Newton per meter square. Half rho density I put SI net, P2 square minus V1 square. Q square I have taken, right? And this is I have taken here as centimeter square. So 20 square minus 40 square. Centimeter is 10 power minus 2. So to convert it into meter, I have to multiply 10 to the power minus 4. Correct? Right only. Centimeter square. 10 to the power minus 4 is going to come out here. Hmm. But if you take this calculation, I think 400 will come. 6 to 5, 5 minus 3, 4000 will come if you take like this. Correct? If I take only this. Okay, again check calculation. So 30 by 1000 has come, and this q square I have taken. So 1 by 20 minus 1 by 40 square. This is centimeter square, 10 power minus 4, right? Area square it is. Okay, it is area square. Area square means area is centimeter square. Square of that it is. Okay, that means it is 10 power minus 8 it is. It is 10 to the power minus 8 here will be coming, because area square it is. So just correct this. This is going to be 8. So 10 to the power 8 will be coming here, right? So we can see how much then it will come, 10 to the power minus 8. So it has become 10 to the power minus 7. Minus 7 it has become. Correct? 10 to the power minus 7, and this minus 10 it has become. Okay. So I think we need to correct this one. Powers we need to correct. Powers we have to correct. So minus 7 it will become minus 1. So minus 10 it will become. Then you take, okay. So 10 to the power minus 10 it is, right. So take out that now. Now that has become 20 square 40 square, and this is 10 to the power minus 10. Now when I take this is 10 to the power minus 5, correct. Now this I have to multiply with centimeters, right, square. This is, sorry, it is cube, right. So I have to multiply with 10 to the power 6. So now I think it is coming as 400. Take care of the unit. I think this is where unit mistake can happen. Answer will be 400 only, but anyway the digits are 400 only, you can match, but take care of the units. Unit calculation you have to take care. Okay, let us move next. Question number 3. A thin horizontal disk is rotating about a vertical axis passing through its fixed center. So this is the center disk, it is rotating. Its angular momentum is LA, about, okay, about this point they are calculating angular momentum. Fixed vertical, fixed center. Fixed center means what? Center is at rest. Center it is rest. Center is not moving. Okay. Angular momentum LA computed about point A in respect to the OB. OB is twice of that they have given. LA. Okay, so first of all, what is the angular momentum formula? Suppose there is a three-dimensional body and suppose center of mass is moving with V center of mass, and about this point we have to calculate. Okay, so about this point we have to calculate. When we calculate, we need this distance. Let us say this distance is r. Okay, so angular momentum about A is angular momentum of center of mass plus I omega, right. This is what we, and all these are vector quantities, so we have to use vectors, right. This is the formula, but here center of mass is mvr, but that is not moving. Note that angular momentum of center of mass we have to take as a particle mvr or r cross p. You can also say in terms of this r cross p center of mass. But here momentum of center of mass is 0 because it is not moving, right. So this is going to be 0 anyway, right. So you have only I into omega. This is what omega about center of mass. So I here is about center of mass and omega about center of mass. So that is not going to change. I think that is going to be same. So magnitude wise, when you calculate LA, which will be I into omega, I about center of mass it is. So because I think in the both the cases it doesn't matter, because the center of mass is not moving, center of mass is at rest, right. Center of mass is at rest. So you can say pure rotation is happening. So pure rotation moment of inertia, when you are considering either this point or this point, it is going to be same, right. Distance, you may say that what about the distance? Is the distance not affecting it? Moment of inertia calculation. So you are not, first of all, you are not calculating moment of inertia about this point. You are calculating moment of inertia about the center itself, because in all these calculations we use calculation, while we use angular momentum about center of mass. I think this can be confusing for many of the students, right. This can be confusing. So here LA and LB should be equal, right. So if LA and LB are going to be equal, then their ratios are going to be 1, right. Ratios are going to be 1. The correct answer should be option number 4. Anyway, we will match the keys afterwards, but let us go with this, because according to the definition, this is how we calculate. You may think that why the distance doesn't matter, because the calculation is like that. Okay, the definition is like that, right. Then let's move next. Question number 4. Consider long solenoid of length L and radius r if any the number of turns per unit length and mu naught is the permeability of the free space. And this is a direct question. I don't know why this type of questions are asking. This is direct formula based question, right? Self inductance if we calculate. So mu naught n square area into length, we can use that. So area is what? It is just circle of radius r, that will become pi r square into l. Direct formula we can go with this, right? Mu naught pi n square r square. Second option. Let us move next. The temperature of metallic sphere of radius r is increased by small amount delta T. So some sphere is there and you are increasing the temperature of that by delta T. The linear coefficient thermal expansion is alpha. The approximate increase in volume. They are asking increase in volume. So that means we know delta V. They are asking delta V is what? Delta V is gamma original volume delta T. We can apply this, right? Gamma, but they are given in terms of alpha, so gamma is 3 alpha volume delta T. We can directly put it or not. Let us put that. So 3 alpha volume of the sphere is 4 by 3 pi r cube into delta T. So it will become 4. Now just take 4 pi r cube alpha delta T, right? This is also a direct question, question number 4. Let us move to the next. Okay, let's go to the next question. Consider two circuits A and B each having two resistors. So we can see here there are two resistors, one is series and one is parallel. One of them has positive temperature alpha, coefficient of, right, coefficient they have given plus alpha, another coefficient they have given minus alpha. Okay, the current through these circuits are denoted by IA, IB current. Initial temperature, resistance of the two resistors is R naught. Initial resistance is R naught. They are identical, means their initial resistance is identical, but their nature is not identical. As the temperature increase, the correct option that describes the variation of current. We have to see the variation of current. So this current IA, I is equal to V by equivalent resistance. We have to take equivalent resistance. So equivalent resistance will be what? R naught, then series 1 plus alpha delta T plus R naught 1 minus alpha delta T. So if I calculate this, what do you get? So if you open this, plus minus term will get cancelled to R naught. That means initial resistance was also R naught plus R naught to R naught. At any other temperature also it is going to be same, so that IA is not going to change. IA will remain same, no change, right? What about IB? IB also calculate. So we need to check equivalent resistance, right? So in parallel, let us calculate equivalent resistance. RB, how it will change? Equivalent resistance R1, R2, so R0 1 plus alpha delta T into R0 1 minus alpha delta T by R0 1 plus alpha delta T plus R0 1 minus alpha delta T. So what happens here? Denominator become 2 R0, 2 R0. These terms will get cancelled, and this R0 square A plus B minus B 1 minus alpha square delta T square. Okay, so this is going to be R0 by 2 1 minus alpha square delta T square. Now see, mostly what happens, this alpha delta T square can be neglected. Now here, if you neglect the second term, then it will remain R0 by 2, and previously in parallel also R0 by 2 only resistance. So if you do approximation, then RB is also not changing. In one way RB is not also changing. If it is not changing, then current IB will be V by RB. So if there is no change in RB, then you can say it will remain as constant, right? Both IA and IB remains constant. But for almost all the practical purposes, we have to neglect the square of that. That's what we do. But if you do not neglect it, then definitely little bit it is lesser, right? It will not remain same. It is going to decrease. This resistance will decrease, and as the resistance decreases, I will be increased, right? This decreases, this will increase. So IB should increase, IA remain constant. So this option can also be possible. Now it depends what should we take. There will be a confusion because we have seen questions in thermal physics. We are doing this approximation actually. Alpha square terms we are neglecting even in JE or any other place we are neglecting. But now best option will be what? We need to choose the best option. If you don't neglect, then it is decreasing, then current will be increasing. So you can go with this if you want exact, but if you want approximately, you can go for this approximately if you go. But they have not told that IB remains constant approximately. If they say approximately word, then definitely this can also be correct. But here there can be this confusion. I think people may, some of the people may go for this first option. So I think NTA need to also consider this. They need to consider little bit because alpha is very small. Alpha comes of the order of 10 to the power minus 4 or minus 5. Square of that becomes 10 to the power minus 8, minus 9, minus 10, which is negligible. So they need to consider this, right? Okay. Question number 7. A beam of light falls on a metal surface such that photoelectrons are generated. That means it's a question of photoelectric effect. If power of light source starts decrease linearly with time, then variation of photocurrent and magnitude of stopping voltage with time is best. So first of all, they are saying question is very simple, that in a photoelectric effect, power is decreasing linearly. So power is what? Power is N into E by T, right? Total energy by time. That's what is power. Power also involves number of photons per second, right? Power of the light source start to decrease linearly with time, then variation of the photocurrent and magnitude of stopping voltage is. So stopping voltage and current. So we know current depends on what? Current. Current depends on what? Hmm? Current depends on intensity, right? Intensity. Number of photons per second. So here when they say power decreases, means here number of photon per second is also involved here. That's the number of photons per second. That intensity definition is not the normal definition of intensity. That is the electron, this photon flux. So n by t is the definition of photon flux or number of photons falling per second, right? So that affects the photocurrent definitely. But here in the question, when power is decreasing, means what is decreasing? Number of photon per second is decreasing or E is decreasing, energy is decreasing. So that can be a confusing question definitely, right? The beam of light falls on metal surface so that photoelectrons are generated. The power of light source start to decrease linearly with time, then variation of photocurrent I and magnitude of stopping voltage. So see, first we think about, suppose number of photon per second decreases, right? Number of photons per second decreases. Then what happens? In that case, only current, photocurrent will get affected. Stopping voltage does not change, right? Suppose if I make that assumption, that only the intensity is changing basically. So if I say only intensity is changing, number of photons per second changes or it is decreasing, so current will also decrease linearly definitely. So this option cannot be taken. Here this option can be taken, that current is decreasing, right? So if I take current means changes because number of photon per second decreases, but then in that case the stopping voltage should not change. So this can be ruled out. This also is ruled out. This can be taken, right? This definitely cannot be taken. So here when they have defined this power, how are they defining it? number of photons per second is decreasing, or in that case E will be constant. Or if energy is changing, energy of the, that means frequency changing, then in that case n by t has to be taken as constant, right? In that case you have to consider like that. In that case only frequency will change or stopping voltage will decrease, but current will not change. So in that case, if current is not changed, and then this option is also possible. So either this or this can be possible when you make some assumptions like that. Can you take both changes? Both how can change? See, it will depend again what are you taking, because if you take the definition of current here, photocurrent, photocurrent, photocurrent is n into number of electrons by time. So definitely photocurrent is proportional to n by t. That's all, right? It is proportional to n by t. So if I say that E is only changing, right, or if E is changing and by T is not changing, then photocurrent will not change. So I told two criteria we need to take, right? And what about stopping voltage? If I take stopping voltage, so we know E into stopping voltage is equal to energy minus work function, right? So stopping voltage, this stopping voltage is proportional to, we can say proportional to energy minus work function. Okay, so both criteria can be there. 2 and 4 can also go together, means it depends on what conditions. Clearly conditions are not mentioned. So as I told that two options are possible, I think the NTA did not consider properly this thing. So photocurrent, but according to NCRT, what is mentioned? That you see, NCRT what they are saying. So power refers to what? Is power refers to only energy? No, no, no. We cannot do like that. Power power get affected both by photon flux as well as this. Okay, so this can have two possibilities. So if so, this is the first assumption. If E is constant, if E is constant, then power is proportional to n by t, right? N by t, and photocurrent is also proportional to n by t, right? Photocurrent is anyway proportional, so we can say that photocurrent is proportional to power in that case. So as power will decrease linearly, so photocurrent will decrease linearly. So in that case, voltage will not change. Note that because we have kept constant. So Vs, in that case voltage, stopping voltage has to be taken as constant. Okay, so that will be the answer, this one. But if you take again other possibilities also there, if so two possibilities are there. If n by t is constant, n by t is constant, then power will be proportional to E. So that means energy is decreasing, right? Energy is decreasing, this is constant. So in that case photocurrent will be constant, photocurrent will be constant. But because E will be decreasing linearly, so this will also decrease linearly. So Vs will be proportional to, in one sense it will be proportional to, not exactly, but similarly it will be proportional to. So E you can write as P, so you can write as P minus some factor, it will come. It is really proportional to, like not exactly but almost similarly. So so we can consider like this, linearly it will be decreasing. So only thing, the slope will also be remain same, but that factor may change. Factor means this phi and other factor intercept on the graph may change. So this is the another criteria. So both these options are possible here, and they has confused again everyone. Questions they have not set properly. This question. Okay, let us move next. We cannot say both happening. Can we also say both happening together? No, both cannot happen, because suppose if both of them is happening together, that means n is also changing E is also changing, N by T and E both are changing. If the product is changing linearly, so that cannot be taken into consideration. I think individually only you take. If you take this also, then what is the nature of variation of N by T and E? Their product must be linearly changing. Then you need to make separate cases there. Okay, that we cannot make. So let us go to the next question. Question number 8, an ideal Zener diode with breakdown voltage of minus 3 volt reverse bias with negative input voltage magnitude of. This is just a Zener diode now. In the question, I think they are creating a confusion by writing minus and this that. Why? Why? There is no need. We know it is reverse bias. We know all that. They are just doing confusion here. So we already know that this is plus and this is minus. So this will be higher voltage, this will be lower voltage, right? So total voltage that they are applying minus 3 volt is reverse bias with negative input voltage. So this input voltage, this voltage difference is 5 volt, and this voltage difference they are given 3 volt, right? So they are asking voltage difference between it. Simply let us take this as V2. This is V1 and this, so total V is equal to V1 plus V2, correct? So V2 will be V minus V1 simply. So 5 minus 3 U2, that will be 2 volt. Simple. Unnecessarily by giving signs they try to confuse you. Okay, let us move next. Question number 9. The measurement of viscosity of liquid using terminal velocity experiment. Spherical balls of same radius but having different density are used. Variation of terminal velocity with ratio of density. So first of all, let us write the formula for terminal velocity. Do we remember terminal velocity formula? 2 by 9 rho eta g r square 1 minus density of liquid by density of object. This is object density, I think. Correct? I think this is the formula as far as I remember. 2 by 9 equals g rho naught r square. Okay, I'm not going to derive it. I think this is correct. Okay, so what is the question? The variation of thermal velocity with ratio of density. I think this is the ratio of density. No, no, this is object and liquid. Liquid density will be same here. Object density, the ball density is changing, right? Variation of terminal velocity v with ratio of density of spherical ball and density of liquid. Liquid density is rho and ball density is sigma. Okay, so they are saying that uh, same radius but having different densities are used. Spherical balls of same radius but having different density. Okay, so that means object density rho naught we are changing. Rho naught we are changing. So what will be the effect of this? They are saying rho naught we are changing. So if you see that, let's write terminal velocity as 2r square by 9 eta g. This I will take. That means density of object minus liquid, right? Ball density is sigma and this density is rho. This is what it is. That's the formula here, right? Ratio of terminal velocity with ratio of density of spherical ball to density. So spherical ball means sigma by rho. Sigma by rho. That means let's take rho common then. Rho you have to take common. So 2r square 9g. If I take this common, then sigma by rho minus 1 it will be, right? Anyway, this sigma is not changing, rho is changing. So what happens then? Because rho is changing, object density is changing, so this ratio will be changing. This is going to be constant. Okay. Now they are asking that which type of graph it will be. So this is like y is equal to some constant, it is m x minus 1, like this type of graph it is. Okay. So if I put x is equal to 1, y must be 0. So it should start from that. So either this graph is not possible because it has to start from, means it has to cut the x-axis. So y is 0 when x is 1. So these two are not possible. What about these two cases? You check that. This is anyway not matching, right? This is not going to match. This only will match because at this point we can see that when this ratio is 1, y will be 0. Y means the terminal velocity, right? Done. Let's move next. Two planets P1, P2 with equal masses have radius R1, R2. Okay, radiuses are given. The escape velocity and escape speeds of P1, P2 are given. Direct push. I don't know why they are asking. Re-NEET they are doing or what they are doing. They need to ask difficult questions. Come on. So this is escape, escape speed formula. Escape is speed formula. What is the escape speed formula? 2 what? 2 gm by r. 2 gm by r. R is the radius of that planet. M is the mass of that planet. So two planets P1, P2 equal mass. Masses are equal only. Have radius different R1, R2. Okay, and that they have given. The escape speeds V1, V2. We have to take the ratio V1, V2 ratio. V2 by V1. So let us take V2 by 1. So this is V2. This is V1. So when you take this numerator is constant, so this will become R2 here and this is R1 here. Correct? R2, R1 will be coming here. So we want to check here this what it is. Directly na, they have given here that R2 is or R1 is 2 times. So that will become root 2. Where is the calculation? I don't understand why these two questions are there. Masses are equal, radius only. What are they asking here? What they want? Okay, let's move. And AC voltage is given, okay, is applied to series LCR circuit, then the current amplitude in this circuit is, so they have given LCR, they are asking current. Again, what they are asking, why they are asking, I naught is voltage by impedance, right? Impedance Z you calculate. Z everyone knows how to calculate, root under XL minus XC whole square plus R square. This calculation we can do or not, right? We know how to do this calculation, correct? So R is given. You need to just calculate XL XC first. So what is XL? Tell me, what is XL? XL is omega, and omega is how much? Omega is this 2000, right? 2 into 10 to the power 3. Inductance is what? L, 10 milli. Milli means 10 to the power minus 3. Override this become 20. Then what is Xc? 1 by omega c. Omega is again 2 into 10 to the power 3. And what is capacitance? Capacitance is 25 micro. 25 into 10 to the power minus 6. Then Xc will be what? This become 50, right? So 1 by 5 will become, correct? 1 by 50 will become, so that 0 and this 1000 you can take, then 10,000 10 to the power 4. So 100 factor will come. This is also going to be 20. So these are 20, 20. So XLX is gone, right? XLX is gone. So that means Z is nothing but equal to R square under root R, which is R is how much? 100. That becomes, this means it is resonance. That's all. So this resonance means voltage they have given, peak voltage 200, 220. Correct? Peak voltage they have given 220 divided by current amplitude only they are asking 100. That is going to be 2.2 ampere. Correct? Right? That's the right answer. Let us move next. Simple calculation it is, right? Two identical inductors are connected like this. Okay. I think you can see diagram. Two are in series and another is parallel case. Time varying current is flowing. So some current which is varying with time is flowing. The induced EMF between points A and B for configuration P, ECP, and that of configuration Q. Okay, so here A and B means these 2 points, this point A and this point B. That means across the first one. And here A and B means total, this total parallel. Okay. that induced EM they are saying. Ratio we need to calculate. Hmm? Calculate the ratio. So first we should know that when we are calculating here in series, so each inductors are identical, right? Let us take LL. This is also LL. So when you are taking first case, so EMF across that P, first case what they are saying is L di by dt. L di by dt. Magnitude I am taking. Okay. I am writing magnitude, otherwise minus sign you can also give. Okay. Next, if you take here, in this case, definitely in this case they are parallel, so L equivalent you have to take, and EQ L equivalent LL just like resistance only, LL become half, right? So L equivalent in this case you have to take as L by 2. So minus L equivalent, which is L by 2, and di by dt. The current rate of change is same only, same current is passing. So when you take the ratio EP by EQ, so here what will happen, this factor will get cancelled, 1 by half, so 2 will come, right? So the answer will be just 2, first option. Fine, let's move next. Three identical capacitors PQ and S, each of the capacitance C are connected like this. PQ, each have the same capacitance C, voltage V, energy stored in P, and total energy stored in this. Okay, ratio. So first of all, tell me what is the total C. So C in series becomes C by 2, right? That becomes C by 2. C by 2 and C becomes C equivalent is how much? C by 2 plus C. That becomes 3C by 2. So total you know, and voltage is there. So energy, total energy will be half. How much? Half C equivalent into V square. Correct? That means 3CV square by 4. That's the total energy. Now I want energy here only in this first one. So note that here also voltage is same, but they are two are there. So voltage need to get divided into half. So voltage across P will be V by 2 definitely. Voltage will be half. So you calculate UP you calculate. So half C, C only. Voltage is half. So V by 2 whole square. So calculate this C V square, 2 square 4 into 2 8. This is what you are getting. So take ratios UP by UP. So 1 by 8 factor here it is. Here 3 by 4 factor is there. 4 into 2 will get cancelled. So 1 by 6 is coming. Right? 1 is to 6 is coming. First option only. Let us move next. Question number 14. A conducting loop of finite resistance lies in the xy plane. So some loop is there. They have not given the diagram, but you assume some loop is there. There is constant magnetic field in the direction in z direction. That means it is coming out. Right? Magnetic field is coming out. The area of the loop varies. Area of the loop is varying. The figure correctly indicates the qualitative behavior of power dissipated as a function of time. Power we need to find out. So area changing. So what is the EMF induced? What power formula is what? We can use V square by R, correct? V square, because voltage we can calculate induced voltage. Resistance will be constant. Area may change, length will not change, right? Area is changing. Conducting loop of finite, they have given resistance is finite, that means resistance we have to keep as constant. Okay, so power formula will be using as V square by R. This V is the induced voltage, magnitude of induced voltage. Magnitude of induced voltage you calculate. Magnetic flux V into area, right? So B is coming out, V is constant, dA by dt you have to do differentiate area. So when you differentiate area, A naught comes out. One differentiation 0, sine differentiation will become cos. This is what V. Now you put it here. So power is equal to B square A naught square cos square T divided by R. So power is proportional to cos square function of time. Cos square function of time, where which graph gives us this only, right? cos square function, not sine. This is like sine square, right? Cos square will go like this one. Okay, fine. So that's the answer. Let us move next. And also, I will tell one more important thing. Check out whether the graph will be exactly like this or not exactly like this. By just looking, it may look like the graph is like this, but at this point, it may not be like that. You just try to check. Generally, sine square graph will make it like this. But is this the actual graph? If you ask me, I will say no. You please think about it. Even technical thing they are not checking, I think. NTA is not checking the technicality of that. Just superfluous it is. Like how it is. This point, it will become totally different graph. Okay, anyway, you check it. Let us move next. This will be the answer here. In an adiabatic expansion, the temperature of 1 mole of an ideal monatomic gas is decreases from 60 to 50 K. The work done by the gas in the process is, what will be the work done by gas? Adiabatic process it is, right? Gamma is given, temperature is decreasing, work done by the gas. So delta Q is 0, delta Q is delta U plus delta W. So work done we will calculate using minus delta U. Delta U is and CV delta T. So, and we know that CV is equal to R by gamma minus 1. This we can substitute here. So delta W is minus N R by gamma minus 1 delta T. Now delta T is given here, I think. Directly we can substitute. Number of moles 1 mole minus 1 R. R we have to substitute, right? 8.3. Gamma is 5 by 3. 5 by 3 minus 1, 2 by 3 it will be. Correct? Delta T means 50 minus 60. So minus 10 it will be. So work done will become positive. Okay. So just take tan factor will get cancelled. 83 will be there, right? Into 3 by 2 will come. Check out this. So 9, 8 into 3, 24 by 2. So 124.5. 124.5, that's the correct answer. Let us move next. Consider a particle moving along a straight line whose position function at a time is given by the position is changing, right? Where alpha value. So why not substitute that? Okay. Position means it is like x. I will write this as x. Alpha is 1, so t square minus what is beta? Beta is 660 plus what is gamma 5. Okay, this is the function. The average speed. Speed they are asking. Note that they are asking speed from 0 to 6 second. Speed. So whenever they ask speed, right? Speed means total distance by time. How will you calculate distance? Distance. You need velocity time graph. In velocity time graph, shift the graph in the upward direction because negative velocity you should not take. Okay, so first let us calculate velocity time graph. So velocity you calculate dx by dt, it will be easy to do tt minus 6. This we can do, right? This graph is easy to plot. Velocity versus time graph. When time is 0, velocity is minus 6. And when velocity is 0, time is 3. Right? So this graph anybody can draw. This graph will be going like this, is straight line. Of course, negative side we don't have to take, we have to take this side only. This is the graph, right? And we have to take 0 to 6 second. 0 to 6 means here, and you know the graph is going to be symmetric because this is 3, this is 3, these angles are equal. So if this value is 6, right, this value should also be 6 only, correct? So that means total area you take without any negative sign. So add this area. So distance you will calculate from this. Distance will be 2 times of this area. This area is how much? Half into base. Base is 3 into height is 6. So you got 18 over, right? So speed, average speed is distance 18 and time total is 6, right? 6 second only. So that comes as 3 meter per second. Correct. So that's the answer, 3 meter per second. Let us move next. Fallen table presents part of electromagnetic. This type of question definitely comes. Which electromagnetic has what application? X-ray is used where, gamma rays is used where, like that. Useless question type. This is your theoretical question. What they can change in this? Always you remember this type of question comes in it. Microwave, purifying water for warming food, right? Microwave oven we are using. Ultraviolet rays, purifying water. Gamma rays, treating cancer. Radio waves, communication, right? So P will be 2, P will be 2, Q will be 1. This is the only answer time. Correct? P is 2, P is 2, Q will be 1, R will be 4, and S will be 3. Over. Let's move next. An ideal gas is made of polyatomic molecules. Each of the molecules has 3 translation, 3 rotation, and F number of vibrational modes. Note that F is not the degrees of freedom. You will confuse. Let us keep this as N to not confuse. Let's keep this as X if you want. Let's keep this as X. Okay. They are asking us to calculate X only. Okay. So each molecule has three translation, and three rotation, and X vibrational mode. So note that for X vibration mode, you have to multiply X into 2. Then total degrees of freedom you can calculate. Degrees of freedom. Each molecule degrees of freedom will be 3 plus 2x. Okay, 6 plus 2x, because each vibration is associated with 2 degrees of freedom. If the ratio of heat capacity Cp by Cv is given, so what is Cp by Cv? Cp by Cv ratio gamma is 1 plus 2 by F. Can we use this formula to calculate this? Let us try this. F you calculate. Cp by Cv they have given here as 8 by 7. So 2 by F becomes 8 by 7 minus 1, 1 by 7. So F becomes 14. If F becomes 14, substitute. So 14 is equal to 6 plus 2x. So 2x becomes 8, x becomes 4. So x must be 4 here. Do not get confused with symbol. They will always try to play with symbol. Whatever I remember that symbol, I will use that only. Whatever question I will that change for my sake. Right? You do like that, then it will be easy. You will not make mistake. Otherwise, this app you will confuse with degrees of freedom. This is not the degrees of freedom. Okay. Done. Let us move next. A unit positive point charge is taken slowly through an infinitesimally thin tube that is inside charged dielectric sphere of radius r having uniform positive charge density. I think this is the question. Full sphere is there, charge density. Okay. As shown, the initial and final positions of the charge are marked by. So charge is moving from A to B. It is going along a rod, thin rod. Okay. Infinitesimally taken slowly through an infinitesimally thin tube. Okay. Distances are 2 or 3 are they have given. In this process, magnitude of total work done by on the positive on the point charge is. Work done on the point charge we have to calculate. Okay. How do we calculate work done on the point charge? Unit point charge is taken slowly through an infinitely thin tube that is inside a charge having uniform positive charge density. Initial final positions. Work done does not depend on path, so can we calculate potentials at A and B and then take work done as charge into potential difference? That's what we can do. So potential, how do we calculate? Think about calculation potential. Initial final positions are given. They are saying that charged dielectric sphere, charged dielectric sphere. What does that mean? Charged dielectric sphere of radius r. Okay, that means it is uniformly charged. So volume charge distribution it is, right? Okay. But anyway, you are moving from outside point to outside point. You are not moving from inside point to outside point. Both the points are outside only. So potential outside a sphere we will write, right? So if there is a sphere which is, let us say, uniformly charged, right, like this. So for point outside this radius distance r from center, potential formula is same as point charge kq by r, total charge here is q. Like that only we will do. But here they have given in terms of charge density. So let us write this in terms of charge density. So k by r, this charge is charge density rho into volume. Volume is 4 by 3 pi r cube. Right, like this only. Radius is up. So like this we have to use k. If you want, you can write 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Rho 4 by 3 pi capital R cube, and this is small r, right? This 4 pi will get cancelled. So rho capital R cube by 3 epsilon naught r. This formula we can remember for potential. Small r is point outside. So we need to calculate work done means charge. This charge is how much? Unit positive charge. Some charge, let us say q, that is value is 1. And you are going from A to B. So VB minus VA we have to calculate. So calculate this, how much difficult it is. No. So charge is anyway 1, unit positive charge. VB minus VA. So this we will do, right? 3 epsilon naught. First of all, for point B, that becomes 3R. That becomes 3R. So why not I will take this common? It is better to take this common, right? This term you take common. So rho R cube by 3 epsilon naught I take common. So 1 by final position it is 1 by 3R minus 1 by 2R. Now you calculate this. Okay. So I think this calculation we can do. Rho cube by 3 epsilon naught. Here it will become 6R and this will become minus 1, I think. Minus 1 it is going to give us negative, I think. Okay. Magnitude anyway they are asking. So calculate from here how much it is going to give. So magnitude, if I calculate magnitude of this one, then we will get rho r square will come, right? 6 into 3, 18 will come, 18 epsilon naught will come. Now check this. This factor 18, right? 18 will match. That's the answer. Fine. Let us move next. Little bit lengthy it looks like, but not very difficult. Okay. Next question. A current I naught flows through a metallic circular loop of radius r. So some current is flowing like this, radius r. Resistance of this segment ABC. Two segments is there, ABC and ADC. Resistance of segment ABC is half of that of ADC. Suppose ADC, this side resistance is R, this side resistance becomes R by 2. Okay, half. Magnitude of magnetic field at the center. What is the magnitude of magnetic field at the center? So magnetic field depends on what? Does magnetic field depends on resistance? Definitely, because here current will divide, right? Current will divide. So you know how currents divided. So this side, let us say current is I1 and this side current is I2. So in parallel, how does current divides? You know that I1. Division of current, let us use current division formula. So total current into total current. So current is inversely proportional to resistance. So if I want here current, so I have to take this resistor R by total resistance 3R by 2 I have to take. So that becomes 2 by 3 I naught. So similarly then I2 will become I naught by 3. Correct? That's how current will get divided, because whichever is small resistance, more current will come. We know this, right? Then write the magnitude of magnetic field at the center. So suppose first is producing magnetic field. This magnetic field is going like this, it will be producing like upward, right? What about this? That is going. So what about this? This is anti-clockwise current, right? Anti-clockwise current means first this I1 is going to produce dot. So this V1 will be dot. And this one which is clockwise I2 that is going to produce cross. So at this center, this will produce dot, that will produce cross. So what is the formula for magnetic field at the center? And that also half you have to take. So magnetic field is mu naught I by 2r, but for half means 4r we have to use. R means resistance. Sorry, mu naught I by radius. So this current let us use for B1. So B1 will be dot, and this is will be I1, radius is same, and B2 will be cross mu naught I2 by 4r. Now first of all check one thing, that you can substitute value. So you can substitute, so which is larger? Definitely, because this I1 is more, so this will be larger. So net magnetic field will be dot only, which will be B1 minus B2. So calculate. So mu naught by 4r take common, which is I1 minus I2. So subtract it. So 2 by 3 minus 1 by 3 will give 1 by 3. So mu naught by 4r into 1 by 3 I naught. This will be the answer. Mu naught I naught by 12 bar. Mu naught I naught by 12. Pi factor will not come. Pi does not come here, right? So this is the answer, correct? Mu naught I naught by 12 bar. Fine. Next, let us move next. Bob B of mass m at rest is hanging vertically. So some bob is hanging, right? Yi mass is string. Length is given. Point A of mass m traveling horizontally with speed. Okay. Hits bob elastically. Elastic collision happens. Bob B rises here. Rises at meter after collision, taking acceleration due to gravity g and neglecting size of bob value. Height. Standard portion. Typical standard portion. Elastic collision has happened. What about the masses? Are their masses same? Point A of mass m travels. So this mass is hitting elastically Bob B. Bob B. What about the masses? Bob B also have same mass. So same mass is there. Correct, right? Bob A of mass m and Bob B of mass m. Both masses are same. So elastic collision is happen, right? Elastically. Correct? Elastically means velocity will exchange. So this will become that, right? That will become this, correct? So after collision, this will come to rest, and this will start moving with 10 meter per second. After that, it will go to some height. Directly use, no, v square is equal to 2gh, h is equal to v square by 2g. So tan square by 2 into 10. So 10 by 2, that means 5 meters. Correct? Direct calculation we will do. Neglecting the size of the bomb. Size is, if size different, might be elastic collision or something else may happen. But they are like point masses. Then let us move next. An electromagnetic wave traveling in lossless dielectric medium having dielectric constant has electric field. Okay, electric field vector they have given. Wave vector among the following option incorrect choice. Direction of propagation of electromagnetic wave is along. So direction of propagation, how do you know? From that phase only we will know. If you see this phase is kx like kz minus omega t, kz. So whenever it is like that, kz minus omega t, right? So that means it is going in positive direction. If it is kz plus omega t, so minus z direction. So this is going in plus z direction. So it is going along. So this statement is correct. We should not choose this. Okay, next, speed of electromagnetic wave inside the medium is speed of the wave. What is the speed of wave? So here we can see that they have given epsilon naught. So dielectric constant we need to calculate mu 1 by, how do you calculate? Root under, uh, sorry, this. Dielectric constant is root under, dielectric constant if I write with the symbol n, that is mu r epsilon r. Generally what happens, this mu r value is normally taken as 1 only. So if I put this, then this is 1 into 9, then we will get as 3, right? So speed is equal to c divided by refractive index, 3 into 10 to the power 8 by 3. So same as this, correct? So this is correct. Speed is this, so we cannot choose this. Next, wavelength of the electromagnetic wave inside the medium is wavelength. Wavelength is how much? 300 meter they are saying. Can you tell anything about wavelength? Because omega we can say. So the speed v is equal to omega by k. Remember omega by k. So 10 to the power 8 is equal to omega 2 pi into 10 to the power 6 by k. So from here we are calculating k as 2 pi 10 to the power 2, right? This got cancelled. K is 2 pi by lambda. So 2 pi by, so from here lambda becomes 100. Lambda is 100 meter, so 300 meter, this is wrong then, right? Wavelength is changing. So this is the wrong option. We have to choose this. You also check for the last one. Magnetic field is given by, no need but check it, because we cannot trust NCA. Magnetic field is given by lesson this. Magnetic field. So these things will be same only. Magnetic field you calculate. So magnetic field B is what? So some B naught will be there. B naught. What is B naught by V? This. What is this? This is the speed of V is the speed of the electromagnetic wave inside. Yes, we know that. What is B by E relationship? B by E relationship is V. Correct. Speed. Is it correct? I think E by B relationship it is. E by B. E by B relationship is equal to C or V, right? This relationship it is there. So B relationship is E by V. Even if we are taking amplitude, E naught by V it should be. This term is same. I think this is also looking wrong. Magnetic field is given by the relation B naught by V sin V square. This is definitely looking wrong. This is also looking wrong, because this amplitude must be E naught by V, right? E naught by speed of light to this. So this is going to be also not correct. The speed of electron. That's why I told you need to check that also. This is also wrong. Then we can choose this also. Then confused, right? No confusion. This is what it is. So two options are coming for this also, right? Check out this. Incorrect choice we have to choose. We have checked that wavelength of electromagnetic wave inside medium. So this is how once speed comes, speed is omega by k. Omega they have given k, we calculated k is 2 pi by lambda. From here wavelength we have calculated. So 100 meter, that's not a mistake in this calculation, right? Because this is coming as correct. Right here calculation mistake is not there, because this comes 100 to pi by 100, k is to pi by lambda, lambda is 100. So two options are coming. Okay, let us move next. 23 particle of mass m along a horizontal x-axis from x equal to 0 to x equal to l. The coefficient of kinetic friction varies as a function of this. When mu naught, okay, something is given here, mu naught alpha constant, appropriate dimension, so that this is equal to 0, mu k is changing. The total work done by the friction force during the motion is this, where g is the acceleration due to gravity. The value of n is. We have to calculate work done by friction, right? So particle is moving along this line, and coefficient of friction is a variable coefficient of friction. So work done by friction is what? Minus friction into, you have to integrate because work done is variable, right? Minus friction is mu naught mu k into normal. Normal is mg into dx. So you can take mg common. Mu k you substitute here. This is mu naught minus alpha x. Correct? Mu naught minus alpha x. into dx. This is what it is, this variable. Now what they are saying is that it is going from where to where? 0 to L. It is going 0 to L. Okay, let us do this calculation. Minus mg mu naught x minus alpha x square by 2, 0 to L. L you substitute, minus mg mu naught L minus alpha L square by 2. Correct. Here they have given one important thing, that so that mu k L is 0. Mu k L is 0 means when you substitute L here, substitute. So that is going to be 0. This is mu naught minus alpha x is L. So mu naught is equal to alpha L. This information also we know, right? And the answer is mu in terms of mu naught. So you need to bring, so alpha L you take as mu naught. So minus mg, this is mu naught L minus alpha L, I take mu naught. So one L will be there, right? So from here we get this as, and half will come. So minus mg mu naught L by 2, correct? This is what it is going to come. Right, total work done by friction force during the motion is, of course it is negative. I think they might be taking as in magnitude. So if you take compare magnitude, m is capital mg L, and so n must be half, n must be half. So we can go with the first option, right? Let us move to the next. Okay, so let's discuss this question. Consider three media P, Q, R with refractive indexes 1, 2. So here three medias are given and their refractive indexes are also given. What we are saying, the medium Q having a thickness. So here the this medium thickness is given, right? Object O is placed at the center. That means exactly in between. That means this distance is half of that, 5 by 2. This is also 5 by 2, right? Okay. If viewed from medium P near the normal direction, apparent depth of O is apparent depth. We need to calculate apparent depth. See, this is rarer medium, this is rarer, and this one denser, right? Denser. So when you are taking this side, this is rarer, this is denser. So it shifts towards that, right? So the height h1 we can calculate. The actual height 5 by 2, 5 by 2 divided by this refractive index, divided by means relative refractive index, so that is going to be 1.25, right? This is 2.5 by 1.25, correct? So that means what will happen here, it will be this, we are calculating the apparent depth. Apparent depth we are calculating. Apparent depth means it is going to be smaller, right? It is going to be smaller. Okay, then next, when you are calculating from this side, this side when you are calculating, it is going to be further away from that, because this side medium is denser, right? And this side when you are taking this medium, this will become like a rarer medium and this will become like a denser medium. So now calculate h2. So same thing, 5 by 2 we have to do, but we have to do it like this ratio we have to take, but we have to multiply. We have to multiply as 1.5 by 1.25. Okay, so calculate this. 2.5 into how much? This we need to calculate. Okay, this we need to calculate. Now take what they are asking, the value of h1 minus h2 mod. Mod means we need to subtract and then take. So which will be bigger, that you find out, which will be bigger. Definitely this is bigger. So you take h2 minus h1, you calculate. H2 minus h1 you calculate. Mod. So when you take this, h2 minus h1, this factor I will take common. 2.5 by 1.25. This become 1.5 minus 1, correct? That become 2.5 by 1.25 multiply with 0.5. So this is going to be how much? Half of this. This also become 1.25 by 1.25. So that becomes 1, right? So the correct answer for this question is option 3, right? I hope you understood. Consider a fixed uniformly charged insulating sphere with radius r and total charge q. If point charge minus q is less, very less than q, with mass m released from So what is there saying? Fixed uniformly charged insulating sphere. Insulating sphere is fixed with radius r and total charge q. A point charge minus q with mass m is released from rest at a distance 3r from center of the. They have not made any diagram. Let us make this. This is center and this distance will be 3r. Right? Total charge is q. It's like an insulator means charge is spread everywhere. This charge is small q minus q. This charge is plus capital Q. Right? From 3 are released. When the point charge reaches the surface, its speed is. They are asking when this charge reaches here. What will be speed? Initial speed is 0. What will be the speed here? Again, direct question. Work done formula you have to use. Work done is charge into potential, change of potential, right? That is going to be change of kinetic energy half mv square. So charge value magnitude wise, let us take Q. Change of potential. Potential formula you calculate. So potential here at the surface potential will be, here potential will be, this is V2 K Q by R. Here potential will be K Q by 3R, right? So when you take change of potential, V2 minus V1, KQ you take 1 by R minus 1 by 3R. So how much do you get change of potential? KQ by 3R, 2 factor also comes. Now you put it here. So 2 by 3 KQ by R half mv square, right? So from here V you can calculate. V will be under root K can be written as 1 by 4 pi epsilon naught, right? 4 pi epsilon naught, that is K, right? And mr also will come in denominator. This will come as 4 small q capital Q. Check out. Which one is the correct answer? Factor 3, what happened to factor 3? 3 is also there, na? This 4 gone and 3 is also there. So 12 will come here. Correct? Here 12 will come. This factor 3 was there also. This factor 12 will be there. So 4 into 3 you can take. So 3 factor will come. Correct? 3 factor will come. This one is going to be the answer. Fourth option. Correct? Q by 3 f pi epsilon naught m r. Fine. So like this type of questions are coming in that. So let's move to the next question. A car travels on a circular race track of radius 50 meters. Okay, circular radius, which is banked at an angle of theta. If the car travels at a speed of 10 meters per second, then the wear and tear on its tire is minimum. Minimum wear and tear is happening. Taking the acceleration due to gravity to be this, the value of theta will be. What is that minimum wear and tear means what? That means is the friction minimum. Minimum friction is acting. Yes. So suppose this is the track and some angle theta is there and this is a car which is going in this radius. Circular turn it is going, right? That's the radius r. So suppose if this car is going with such a speed, what should be the speed that we can use? Friction is also there, right? Friction is definitely there. and banking is also there. So I think you need to think of the formula for friction that we need to consider. Hmm. Friction formula we need to, otherwise we need to think about it. They have given the speed, they have given, okay, they have given the speed. So should we take the minimum speed or maximum speed condition? Yes. If the car travels at a speed, this friction, friction which is going to act as mu times normal. Normal will be mg cos theta only, right? Okay, let's try to draw free body diagram. So mg will act like this, and note that normal will be acting in this manner. Normal has two components here. This angle is same as theta, so normal component and cos theta, normal component and sin theta. Right? Suppose this has a tendency to uh, slide downward. So friction will be acting in this way then, right? Friction will be acting this way. So if I balance normal cos theta with mg, normal cos theta with mg, I think friction also we need to resolve. Friction we cannot just balance like this way. So if this is theta, so here we want friction to break along this, right? This will be theta, so this also friction cos theta, this will be friction sin theta, right? Friction sin theta, friction cos theta. Okay, so if I balance normal cos theta plus friction sin theta is equal to mg, and this way normal sin theta minus friction cos theta is mv square by r. When is wear tear minimum means friction should be minimum, I think. Wear tear minimum, I think when they say wear and tear is minimum, that means friction should be minimum, because friction only causes wear and tear, right? So how can we say friction is minimum? How can we say friction is minimum? Hmm? How can we say friction is minimum? Friction we need to calculate, right? How to calculate friction? Should we eliminate normal? If I eliminate normal, then friction can be calculated. Then we can try, right? Normal can be eliminate that. Normal can be eliminated, and friction can be calculated in terms of theta. In terms of theta, we can calculate. And when will be tan theta minimum? We can try that, right? Speed is constant. Should we consider if the car travels at a speed? No, no, we cannot see speed because speed changes, right? Speed can be maximum, speed can be minimum. The speed will also affect the calculation, right? Okay, I think let us try to eliminate normal and get friction in terms of that. Let us try to do that because friction has to be minimum. How can we eliminate normal? I think normal you calculate from here and divide it. So can we do that? Let us try that. So from here normal cos theta, normal sin theta. So normal sin theta by normal cos theta. Let us do that. That means we will calculate tan theta. So from here become f cos theta plus mv square by radius, and from here mg minus f sin theta. Okay. Wear and tear on its minimum means, can we take friction as 0? Can we just think friction as 0? That's all, over. No friction. Friction has no role. I can save time in calculation because minimum friction can be taken as 0, isn't it? If I say friction is 0, then game is over. I think the game is over because then we can simply calculate. Suppose friction is not acting, then we can directly take here, right? If friction is not there, let us say friction doesn't come, then normal cos theta. If friction is 0, then normal cos theta is mg, and normal sin theta is mv square by r. Then I think that is what they have telling tan theta. Now from here you calculate tan theta. So v square by gr. I think this is what they are asking. So we don't have to think any much. We don't have to think. No need to think. But we could have thought if they have given coefficient of friction and they have given everything and then they asked to calculate speed. This word is very important. Minimum wear tear means friction is 0. Let us take 0 friction. So if I take 0 friction, then tan theta comes as v square by gr. V they have given. V is how much? Tan. So tan square. G we take as 10. Radius they have given 50. So that will become 100. So 1 by 5 it will come. So theta will be tan inverse 1 by 5. This we can take. No need to think much because then friction is 0. So it's like a only banking is helping it to move. If banking is not there, then he cannot move, right? So he is taking a circular term because only banking is there. Okay, that means this is a smooth surface. Then next question. A frictionless circular wire of unit radius is fixed on the horizontal plane. Frictionless circular wire. What does that mean? Frictionless circular wire. That means a smooth circular wire of radius is kept on a horizontal plane. 2 point particles of unit mass start moving simultaneously from point. I think this diagram is given here. Okay. At an angle, one is at an angle of 90 degree with identical uniform angular speeds in opposite direction. And meet again at point B. Okay. From point A, 2 point particles of unit mass start moving simultaneously from point A. Okay, theta is the angular position measured from x-axis. So initially they are at 90 degree. Opposite direction meet again at point B. During this time, which of the following figures schematically represent the magnitude of total linear momentum P of the system as a function of theta? Total linear momentum. Total linear momentum. Are they going with same speed, moving simultaneously from with identical uniform angular speed? Okay, that means they are going same. So this is the circle, right? And they have started exactly at this point A, which is exactly here right now. And they have started moving in this way, one like this, and they are moving equal speed. So they are moving, meeting exactly at point B. They are saying represent the magnitude of total linear momentum. Total linear momentum magnitude. Total linear momentum magnitude. What does that mean? Total linear momentum. So linear momentum of 1 plus linear momentum 2, or are we talking about the linear momentum of the center of mass? That also we need to think about total linear momentum system, or what? What are they saying? Total linear momentum P of the system. System they are saying. System means both the particles, but note that linear momentum is a vector quantity. Linear momentum is a vector quantity. So suppose if you consider this particle coming at any point, they will be rotating with same angular velocity omega, right? So once suppose they have come here, they are coming with the same velocity v, right? Or they have started here. So we started means same initial velocity v. So initially their angular and linear momentum is 0 because they are cancelling out each other. So it must start from 0. It must start from 0, we should know, because initially when they have started at this point, its velocity is this way and that velocity is that way, opposite, right? Because it is rotating like this way, it is rotating like this way. So velocity omega r is there, but they are exactly in opposite directions. So when you take linear momentum, mass into velocity, and they have same masses, so initially the system does not have any linear momentum. So the graph must start from 0. So you see here it is not starting from 0, not starting from 0, not starting from 0. This is the only answer. Okay. And when it is going like this way, pi by 2 when it comes here, what about this point? Here also it must be 0, because when it is reaching here, it will have velocity like this will have velocity like this, correct? Again it will be 0. So that's the only answer which is matching. No need for further calculation. Okay, done. Let us move next. Three identical PN junction diodes D1, D2, D3 are connected across a battery as shown in the figure. If the width of the depletion region of D1, D2, D3 are W1, W2, W3 respectively, then the correct option is. So I think we need to see forward or reverse, right? So if you take here, you know, in the forward the depletion becomes smaller and in the reverse it becomes larger, right? So if you take uh, first one it is in forward bias. Second is not connected at all. Third is reverse bias. This, right? So definitely if they are all identical, no? All are identical, so normally they have same width of the right depletion region. But if you keep in forward bias, it will decrease, and in reverse bias it increases, right? So forward bias, it must be smallest. Forward bias, so first D1 we must have smallest. D1 has W1, W1 must be smallest. Then W2 is a medium, and in reverse bias it has increased, so this must be largest, right? Let us go next. The lens combination as shown in the figure consists of two lenses L1, L2 of focal length. Focal lengths are given, right? The position of the image formed is. Where is the image formed? So when these two combinations are there, we can try to apply the logic that the image formed by the first will act as an object for the second. So where is the image formed by first? Let us calculate that quickly. So let us calculate 1 by V minus 1 by U. U is how much? Minus 30 is equal to 1 by focal length. Focal length for first one is plus 10. So 1 by V, this is plus, this will become minus 1 by 10 minus 1 by 30. So that becomes 30, correct? And this will become 3 minus 1, 2. So that's why V will become 15 centimeter. So 15 centimeter from the first one. Note that this side 15 centimeter, right? But the rays will be passing from like this, rays which will be passing like this way. So this is the image of first which will act as objects, but from here the distance will be how much? Because this is 3, total is 15, 15 minus 3, 12 centimeter, 12 centimeter, but that is going to act as a virtual object, right? So you have to take as plus and then apply for the next case. So 1 by V minus 1 by U. So object you have to take as positive plus 12. 1 by V minus 1 by U is 1 by focal length. Focal length is minus 10. So minus 10. Apply this 1 by V, 1 by 12 minus 1 by 10. So can we take how much? 60. 12 into 5, 6. So minus 1 by 60. So V will be minus 60 centimeter. Minus 60 means what? Minus 60 means it will be forming this side. This side, right? Because in this direction it's positive, this is negative. So minus 60 means 60 centimeter this side. So the final image will be 60 centimeter from L to this left. 60 centimeter to the right of the concave. That's not correct. 60 centimeter to the left of the concave lens. This is correct. Okay. Option 3 we can go. And if we have to calculate from the L1, then we can calculate, because this is 3 centimeters, so 60 minus 3 will be 57. So 57 from the first one, that is not given anyway, right? Then let's move next. A solid sphere of radius capital R and mass m is attached at a point to a smaller solid sphere B. So one is bigger, another is smaller. Small is very very small than capital R. Small size, not very small. They have just mentioned small, and mass is also smaller. Mass is smaller, radius is also smaller. Assume that the line joining the center lies along the horizontal. Okay, this line is horizontal. Moment of inertia of the system calculated about a vertical axis passing through IA, and that calculated about a vertical axis passing through this is IP. Okay, the difference, they are asking the difference of this IA minus IB. So let us calculate IA first. About this, when you calculate, so you need to calculate about this for the bigger one. So IA will be what? IA for the bigger one is 2 by 5. That mass of the bigger one, how much? Capital M. 2 by 5 m into r square will come. And for this, you have to apply parallel axis theorem. So here this is 2 by 5 small m r square. That center of mass. 2 by 5 small mr square plus you have to bring here, right, that mass m into distance square. Distance is r plus r whole square. This is what you will get. Okay. Next, similarly, IB you calculate. IB when you are calculating, so 2 by 5 small m r square plus same way 2 by 5 capital M capital R square plus capital M, you have to bring this side, so r plus r whole square. Like this you will get. Now you subtract that. We need to subtract it. What we need to calculate? IA minus IB. IA minus IB will be what? When you subtract this, so 2 by 5 capital M R square. I think when you calculate, this term will go away, right? Because 2 by 5 here, this term whole goes. We need to subtract that only. So small m r plus r whole square minus capital M r plus r whole square. Okay. So let us take common m minus capital M r plus r whole square. Check out this. M minus capital M r plus r, not capital M minus M. Third option will match, right? Third option will match. Fine. Let us move next. Consider that an electron is revolving in an excited state of hydrogen atom with velocity. Velocity they have given. The radius of the orbit is the value of x is. Electron is going in excited state, right? Velocity they have given. The radius of the orbit is this. What is the radius? So we need to know the formula, how speed and radius are related. How speed is related? V is proportional to n square. No, V is proportional to z by n. I think V is proportional to z by n, and radius is proportional to n square. Correct? Like this it is. Correct? Right? Like this it is. So z is anyway 1. So you can say, well, V is proportional to 1 by n. Right? Okay, so how do we solve it from here? We need actual values. We need actual values or what? Or what is the formula here? I think if you remember, this V is V into 1 by n. We can use R is R naught into n square. Okay. like that something is there. So if I want velocity, if I substitute root under 25.6 into 10 to the power 5, and we can just try to replace that. Okay, and we can bring in terms of radius. Okay, let us try to bring in terms of radius, but they have given some values. I think here formulas need to be remembered, otherwise we need to derive that, right? We need to derive that. What is the value of velocity in the first? I think hydrogen first radius we know. Velocity also first radius we should know. Then quickly we can solve it. Correct? We can solve then only, right? Velocity we should know. What will be the velocity if I substitute in terms of r? Root under 25.6 into 10 to the power. Okay, think then think in terms of that. Kinetic energy. Kinetic energy formula half mv square. Okay, and mv square by r is the force k q1 q2 r square. So from here I think we can get velocity. This is how velocity and radius are related, I think. Can we use this? Because velocity and radius relationship we need. Correct? That velocity and that radius. Maybe you can use this. This is better way. Even if you don't remember formulas, we can use this. What we know that half m v square kinetic energy. This is kinetic energy. And mv square by r is k square by r square. Right? So this r will get cancelled. So v square is equal to k square by mr. So v is equal to root under k square by mr. Now let us substitute. E will come out root under k is 9 into 10 to the power 9. Mass of electron will substitute 9 into 10 to the power 9. Radius we will calculate. Radius they have given x into 10 to the power minus 9. If I use this, then velocity becomes, from here you see everything get cancelled, this get cancelled. It becomes e by root x, 10 to the power 9 will remain inside that, 10 to the power 9. Okay. Now we will substitute v and try to solve. V is given as root under 25.6 into 10 to the power 5. This we can equate with e root under 10 to the power 9 divided by root x. Okay, square that, then what will be x? X will be e square into 10 to the power 9 by 10 to the power 10 will come here into 25.6. Now check out here. So 1 extra 10 will remain. So x will be e square. E means this. The square of this you have to do. Right? E is very small, right? Take the mass of electron. Mass I think we have not taken properly. 9 into 10 to the power minus 31 we have to take. Mistake has happened here. The calculation of mass. Okay, so let us square this and calculate r. So here itself we can calculate now. Radius we can calculate directly from it. So r is equal to k e square by mv square. Right, let us substitute 9 into 10 to the power 9 e square. E is what? 1.6. 1.6 into 10 to the power minus 19 square, right? Mass is 9 into 10 to the power minus 31. V square, velocity square is 25.6 into 10 to the power 10. Now you check. I think 1.6 square will do 25.6, they may cancel out. Check that. This 9 will definitely cancel. This 9 and this 10 will remain. Minus 30 it will become 1.6. So 256 will come into 10 to the power here. Become minus 20. Minus 20 square minus 40. Right? And this becomes how much? This becomes 10 to the power minus 30 and 25.6. Extra 10 you take here. This gone, this gone. This 30 gone. So 10 to the power minus 10 minus 9 will come. 10 to the power minus 9 will come. That means x is 1. I think this calculation can be reduced if you know direct formula for that. That is why it is very important for NEET students to mug up the formulas. Mug up the formulas. Mug up the formulas, right? Because there is direct formula for velocity as V naught into z by n, and there is direct formula for radius r naught into n square by z. You should know the formula for r naught and v naught. If I know r naught, v naught, see z is 1 only, na? And if I know this is v at any radius or vn formula, okay, velocity formula for any orbit. So we are supposed to know answer. For J it is not required, we can solve it, but for NEET it is required to remember. Otherwise you need to do the calculation, and if you forget formula it is problem. Better practice so much practice you have to do. Okay, next. Let's see the next question. The mean free path of molecule. The mean free path of molecule in an ideal gas A is half that of another ideal gas B. Okay, the diameter of the spherical molecules of gas A is twice the diameter of molecule B. So what is the formula for mean free path? Lambda is 1 by root 2 pi d square into n. It is correct. This is the diameter, and n is total number of atoms by volume. Just check whether this is correct. Dimensionally we can check, because this is meter square, this is 1, means it has no dimension, meter cube, so it will come. Yes, so this is the formula. Now let us use that. Half that of another ideal. So what they are saying, that two gases, so we will use this lambda will be inversely proportional to d square into n. Let us use that. So for the first case, lambda A you take, this is going to be diameter of A whole square n of A, lambda of B 1 by diameter B square n of B. Now we will use that. So what they are saying, the mean free path in which lambda of A is half of lambda of B, right? This is what it is given. Mean free path of A is half. Diameter of the spherical molecule is diameter of A is twice. Diameter of A is 2 times diameter of B. Then what we have to calculate? Relationship we need to check out. Okay, so let us take this ratio. This is half, right? So when you take this ratio, 1 by 2 you will get, and you will get this dB by dA whole square nB by NA. Now let us substitute it here. So we will get this as half, and dB by dA, dB is going to be half times that, or dA is 2 times, so 1 by 2 square, 1 by 4 will come, nB by NA. So here NA is going to be half of NB, right? NA is going to be half of NB. So that's the correct answer, option 1, right? I hope. A cylindrical quark of uniform Density floats in liquid of density rho 1. If the quark is depressed slightly and released, it oscillates harmonically with time period t. If the same quark floats in another liquid of density, then the similar oscillation has time period 2t, the value of this. So, how does this frequency depends on? Suppose if this is a quark, okay, or any object is there, its density is, let us say, rho, and this liquid density, okay, and it is floating, right now floating, and if you press it, so there will be extra volume submerged, extra volume will be submerged, right? This extra volume will apply the net upward force. So suppose the area is a and you have pressed x, this is extra volume, this volume into density of liquid into volume, this is submerged, right, mass into g, this is the net force. This net force is equal to mass into acceleration, right, but it is restoring, so minus we write, so this axg, and this mass is density of object into volume, which is area into its length, okay, it may have some length, let us say l into, so from here a get cancelled, so area comes as, means acceleration comes as minus rho liquid by rho of the object, uh, into g by l, right, into s, correct. So this is what is omega. Omega is root under rho L G by rho into L. Correct. L is the length. The quark same length we are putting. So omega is this. So time period they are asking. So time period is 2 pi by omega. It is inversely proportional to omega. So object is same. So inversely proportional to omega means it will become here root L G by rho L. So liquid, if you see liquid density, how it is related, so time period is inversely proportional to liquid density. This is the idea, because object and other things are same. That's what you have to apply here. So previously the time period was t, now the time period is different, right? So how it is related? Time period has become doubled. That means liquid density, if you see, it is proportional to 1 by t square, correct? You can check that. So that means liquid density must become 1 by that much square, so 1 by 4 times 1 by 4 times, okay, that means this rho 2 must be 1 by 4 times of rho 1. This we can just check. So rho 2 by rho 1 will be 1 by 4. That's the answer, right? Direct. Next, so this result you have to remember. I have derived it here. For sound waves, the number of notes for fifth harmonic of an open-ended pipe is n, and that for ninth harmonic of the same pipe with one of its end closed is m, then the ratio n by m is. Sound wave if the number of notes for fifth harmonic open-ended. Open-ended means both sides are ended. Open-ended. If the number of notes for fifth harmonic of an open-ended fifth harmonic means what? Odd harmonic only or even harmonic? No, I think it is even harmonic, because open-ended means what? Open-ended means here it will be like this way. Correct? Here it will be like this. So this will be node and two antinode. Antinode distance is lambda by 2. Correct? So this lambda by 2 is equal to L. Right? So what is the formula for frequency? You can derive. Similarly, if there will be two extra nodes will be there. Node, then antinode, then like this. Right? So this become lambda. So 2 or n times lambda by 2, that becomes equal to n, right? And this lambda is equal to speed by frequency. So n times v by 2l. This is the formula for frequency, right? We already know that. We have to remember this. The question is fifth harmonics. For sound waves, if the number of notes for the fifth harmonic of an open-ended pipe is n, and that of ninth harmonic of same pipe with one of end is closed, that means it becomes closed ended. Length is going to be same. So I think we should remember, if it is First harmonic, that means only one note are there. Second harmonic, two notes are there. Like that happens. Okay. So if it is fifth harmonic, means five notes are there. Number of notes for the fifth harmonic. Uh, so that n must be five first of all. Okay, n must be five. And that for ninth harmonic, simple. For closed, what happens? If suppose the tube is closed, then what happens? Only one node is there, right? And let's take next harmonic. Next harmonic, when you take, then you have to take it like this, right? So node, then antinode. So this distance, how much? Because this is 3 lambda by 4 it becomes, right? So that means this is second harmonic, means two, sorry, this is odd harmonic, third harmonic, but there are two notes here. So number of notes means number of harmonics minus 1. If you want fifth harmonic, you can take one extra note, correct? So two harmonic means third note, one harmonic means one note only, but two harmonic, sorry, third harmonic, two notes. Next fifth harmonic, if you take, then extra one notes will come, right? Fifth harmonic means three note. After fifth, seventh harmonic means four note, right? Nine, you can check that. Suppose if you do like this it will come. One, two, three, right? So this will be three notes. So three notes means it is fifth harmonic, seventh harmonic, fourth note, fifth harmonic, nine notes. So M must be five. Fifth harmonic, nine notes. So both are equal, right? The ratio becomes one. Here you need to understand these formulas or the number of notes also relationship. Okay, done. Next, consider the following nuclear reactions. Nuclear reactions are given, masses are given. Okay, the Q value for the reaction, they are asking Q value. So Q means we will calculate. They have given the, for one they have already given for one unit of mass. So how much will happen? Loss, how much happen? Calculate. So its masses are given, now we need to subtract it. So sum of this mass you do, thorium and this you do, thorium and helium you add. So 234.043 and 4.003. So here 238.046. This is the difference, right? Here that is 0. So 0.050 and 0.046. That's the difference we have to take. So 0.004, that's the unit. Okay. So multiply with this in million electron volts. So 0.004 into 931.5. But we want in calculate in kilo. So this is million. Million means 10 to the power 6. So extra 10 to the power 3 you keep it. That become kilo electron volt. Now check this answer. I think this 1000 will go away. So this 4 you have to multiply with this. 20, 41456, then 4 into 3, 12, 9, 4, 36, 37. 3726 it should come. Let's check that. Yes, 3726. Okay. Next question. Let us move next. Which of the following measurement require index correction? Index correction is what? I think it's a practical physics related topic. Measurement of speed of sound using resonance. I think in that we need ind correction, not index correction. Ind correction we need in this. This is not correct because tube ind corrections we do, right? Measurement of resistance, meter bridge also ind corrections are there. That is also not correct. Measurement of gravitation acceleration using simple pendulum. Simple pendulum length corrections we are doing. That is also not correct. Measurement of focal length using lenses in optical bands. Maybe this one is the correct. Okay. In optics, this is related topic of practical physics. Generally, they are not teaching this, but we have to cover that in practical physics, right? Let's move next. In a solar system, the time period of revolution of planet tracing a circular orbit of radius r is proportional to. Solar system, it is going in circular orbit, assume circular. So if you take circular, then you know time period square is proportional to r cube, r cube. This is direct formula, right? Time period is proportional to r power 3 by 2. Yes. Time period only they are asking. Time period of revolution of planet tracing a circular orbit. Okay, let us move next. Consider that this Stephen Boltzmann constant mean displacement law, dimensions we have to think about it. So what is this? This comes in what? Stephen Boltzmann law. What is Stephen Boltzmann law? That is for power, right? Power. Power is what? Power is proportional is equal to this Stephen constant into emissivity into area into temperature power 4. I think this is the formula. Power by area is intensity. But anyway, here we need to note that this we need to see. So this we can substitute in terms of formula here. So it will become E is anyway 1. So power by area T power 4 multiply KB. What is KB? This is power, okay? You should not get confused with pressure. Let's write pressure as small p. Pressure into volume PV. PV is equal to N kBp. Anyway, N also doesn't have any dimension. So KB will become equal to inverse of that. That means 1 by this. So N into T. N does not have any dimension. Number of atoms. So temperature 1 by K with temperature by small pressure into volume. This is volume, right? Then what is the next one? Wien's displacement law. Lambda is equal to d by t, I think. No, lambda into t is constant. Product of wavelength and temperature is constant. So this is v lambda into t it is, right? Lambda into t. Okay, so try to now calculate power. This is power and pressure into volume. This is work. Pressure into volume is work. Power is work by time. So this is work by time. Here t square will get cancelled. Here square will come. Area is like meter square, right? Temperature square. Answer have to be kept in this. So okay, length. Let us write in terms of length. So this is going to be work. Work I will write like this. Then lambda I will write as length. Area is L square. Temperature is like Kelvin square. Pressure volume is again work. Work by time was there. So work by time was power, capital P. So this work got cancelled. So we are getting L power minus 1, T power minus 2, T power minus 1. Check out that. L power minus 1, K power minus 2, T power minus 1. Second option. Okay, let us move next. A ray of light with wavelength lambda is incident on three different photocells, namely 1, 2, 3, and the threshold wavelength of these photoelectric cells are lambda 1, lambda 2, lambda 3 respectively, and the magnitude of stopping potential of these cells are V1, V2, V3. The relation between lambda and threshold wavelengths are this, and this. The correct option is, what is the correct option? Big question it is. Oh, what it is? Electric cells are there, three different photocells. 1, 2, 3. Wavelength of these are lambda 1, lambda wavelength, threshold wavelength. What is threshold wavelength means? Photocell it is, right? Photocells. That means light is falling on it, it is producing current, right? So these photo cells will work, right? It is not like LED. LED means it will emit light. This is almost like a photoelectric effect. So light will fall, current will generate. So light falling must have threshold, right? Wavelength. So wavelength should be there is a minimum wavelength. Wavelength must be greater than smaller than that minimum wavelength, right? So lambda 1, lambda 2, lambda 3 are threshold wavelength, okay, and their stopping potential V1, V2, V3. The relation between lambda and threshold wavelengths are lambda is the incident light, I think, that light incident. So in the first case, you see this lambda which is falling is greater than this. So then this will not happen. Lambda should be less than that. This lambda is less than this. Here it will happen. Happen means current will generate. This lambda is also very less, so this will also happen here. Okay. So in the first case, first one, lambda is more, so this will not produce electron hole pair. The correct option is stopping voltage they are asking. So in the first case, you don't require any stopping voltage because electrons are not being produced. So this one is 0, you can take. So first one we can reject and fourth one also we can reject. Now we have to check this one. So if you see this lambda 3 is much larger than this, or lambda of incident is much smaller. The smaller the lambda, the smaller is wavelength, more the frequency, more the energy. So in this case, the energy will be much higher. Much higher energy will happen means what? More voltage. V3 must be larger. Definitely V3 must be larger than V2. So we can go for second option, right? It is almost like photoelectric effect. Let us move next. Okay, so let's go to the next question. One main scale division of vernier caliper is equal to 1 millimeter. So that's the normal scale, right? So what is the least count? Least count will be how much? Vernier scale tan division 1 millimeter. So 0.1 millimeter, right? Okay, when both the jaws touch each other, vernier scale shift to the left of 0. So what it is? Left of 0. The vernier scale is left of the 0 of the main scale. So that's a negative 0 error. Negative 0 error, fourth division. So 0 error, if I calculate, it is going to be negative. Negative it will be, right? Negative it will be. But the zero error is counted from right side, that we need to note, very important. Some textbooks they have given from left side, but that is not correct. We have to take it from right side. So total of 10 divisions of vernier scale is there, and from fourth is from left, so we need to count from right side. That means 10 minus 4, that means it is coming as minus 6 division, right? And each division is how much? Each division is equal to millimeter. So this is going to give us millimeter, right? No, into least count. We need to multiply with least count, right? Multiply with least count. So minus 10 minus 4 into least count. So minus 6 into 0.1 minus 0.6 millimeter. Okay. Now what we need to calculate? If this vernier caliper measures the length of a wire is 1 centimeter, the actual length we need to calculate. Okay. So 1 centimeter is the reading, main scale reading it is, right? So this 1 centimeter we have to note, it is main scale reading. So what is the measurement? Measurement is equal to main scale reading minus 0 error. So let us calculate what we need to calculate. Actual length we need to calculate, right? If this vernier caliper measures the length of wire to be, okay, actual length is given. No, the actual length we need to calculate. Okay, let us try to calculate this. So measurement, we have to do the measurement means actual length. So main scale reading is 1 centimeter. So 1 centimeter 1 centimeter minus 0 error. 0 error you have to convert into centimeter. So this will be minus 0.06 centimeter, right? Okay, now you have to add this minus and this minus is going to add. Let us add them. So that will become 1.06 centimeter. So that's not given, right? That's not given here. So that means what? 1.04. None of the option is matching. What has happened then? I think if I take this as 4, maybe then we will get. So, but this is not correct. 1.04 is not correct because it's a negative 0 error. It is not a positive 0 error. If it is negative 0 error, we have to count from the right side. Okay, so none of the option is matching for this question. So might be that NTA has to give grace marks for this, right? Okay, fine. A point charge Q is placed inside a cavity within a solid isolated conducting sphere. A point charge kept inside a cavity, solid isolated conducting sphere. Conductor it is. Consider point A, B, C, where magnitude of electric fields are given. The points B and C are at the same distance, right? The correct option is. So they are talking about electric field. At a note that electric field inside the cavity. Here, charge is kept inside the cavity. Electric field inside the metal will not be equal, but this point A, which is inside the cavity, here it is very near, so electric field will be largest. We cannot say electric field is 0 here because charge is kept here. If charge was not there, then electric field would have been 0, but there is a charge here, so that charge is producing electric field here. A electric field must be highest. It cannot be 0, cannot be 0. Now what about B and C? B is equidistant from the charge, right? They are saying point B and C are the same distance from center of the solid sphere. They are saying center of the solid sphere means this one, I think here. The center of the solid sphere means this one. Center of the solid sphere means here. Okay, equidistance, but this charge Q is near to this. Now here there can be again a confusion will happen. Now this is a very important concept. This question that they have used, this is a quality question, you can see. It looks like the point B is near to charge Q and point C is away from charge Q. It looks like, so you can see electric field will be different, but actually it is not. The electric field outside the sphere, the electric field lines are uniform. Uniform field lines happen. So electric field at point B and point C must be same. So electric field at point B, that means option 3. Option 3 must be the correct. This, how will you understand this? This is a very important result you have to note. Suppose if there is a cavity here and some charge you are keeping here. Anywhere you keep charge. If you are keeping anywhere charge, suppose I keep the charge here. So field lines will be here non-uniform. Here the electric field lines density will be non-uniform, but outside the field lines are uniform. Outside this field, so outside this is uniform. Inside the cavity it is non-uniform because charge distance. If you keep charge exactly at the center, then it is uniform field lines, but outside is always uniform. That's a very important concept. They have used this concept. Fine. Let us move to the next. In Martian experiment, the number of alpha particles scattered plotted as a function of scattering angle. We know that it is decreasing, right? I think this number is proportional to sine 4 theta by 2, something like this it is. So as you increase the angle, this value decreases. This answer we can choose for this. right? This is the only answer. Let us move next. Alpha scattering experiment it is, right? Yes. Next, 1 mole of an ideal monatomic gas undergoes a cyclic process as shown. The cyclic process is given total heat supplied to the gases. Total heat we need to calculate. Total heat we need to calculate. So take the process A to B, B to C. How to calculate total heat? So note that delta Q is equal to delta U plus delta W. If you consider full cyclic process, so this will become 0. This will become 0. So for cyclic process, this happens. For cyclic process, right? Total delta Q same as delta total heat supplied to the gas. They are asking total heat supplied to the gas. So we have to be very careful. Total heat supplied to the gas. That means input heat only they are asking, not the output heat. So you should not go by calculating the total heat. Total heat you can calculate, but somewhere heat can be absorbed and heat can be released. They are asking heat absorbed. Okay, so you cannot just calculate the area under this law. You need to take the process like how this first process, if you calculate what kind of process it is, isobaric process. So in isobaric process, write down the formula for heat. Here also write heat formula you write everywhere. So first, what is the formula for heat? Q A B. What is the heat? So isobaric process, pressure is constant. So and Cp delta T also you can write, and Cp delta T. Correct? Right? Pressure is constant. Pressure is constant. Heat process and Cp delta T. N is how many? 1 moles. Cp is what? Cp is equal to what? Cp minus Cv, so Cv plus R. R is what? F by 2 R. So F by 2 plus 1, right? F by 2 plus 1 times R. That is Cp. So monoatomic 3 by 2 you take, so it will become 5 by 2. So 5 by 2 R it is. 5 by 2 R delta T. Okay, so 5 by 2 R delta T. R delta T is what? R delta T is what? Or NR delta T is what? P2 V2 minus P1 V1. Directly we can do P2 V2 minus P1 V1, because PV is equal to NRT. P delta V is equal to NR delta T. I think this NR delta T or R delta T is P delta V. So calculate P delta V. Pressure is same 300. 300 delta V, change of volume 5 minus 2 3. This is what it is. So this we can calculate, and it is going to be positive only. So it is heat absorbed, right? So 3 into 3 9, 9 into 5 45, 100 by 2. This you calculate 2 2 50 2250. Okay, heat absorbed. Then B2C isochoric process, work done will be 0. So change of internal energy, that is what we have to calculate. But again PV they have given. So how do you calculate in this process? So first of all you check the pressure is decreasing. Because pressure is decreasing, so when delta Q you have to calculate for process BC. Work done is 0. Change of internal energy. Change of internal energy is NCV delta T. How to calculate? N is 1. CV is 3 by 2 R delta T. How do you calculate this delta T? So first you write uh, here pressure 300. PV is equal to P into volume. Volume is 5. PV is equal to N in 1 by R. That is temperature, initial temperature. Similarly, P into V, here volume is constant, so this pressure is 100 final into V by R. 500, this is going to be negative, so this is going to be negative means this is released. You don't take this, released. Released we don't have to take, absorbed only we have to take. Then next, total heat supplied to the gas is, heat supplied means here it is released. What about the CD process? CD process will be, again minus will happen in the same way, and Cp delta T you will calculate. When you will calculate and Cp delta T when you calculate from here to here, how do you calculate delta T from here to here? R delta T you calculate for this. So Q C D you calculate. So same way N 5 by 2 R delta T you calculate. Same way N R delta T, how do you calculate? T delta V it will be, right? R delta T, P delta V. So pressure into delta V you have to calculate. So pressure is what in this case? This is 100. Delta V volume, volume 2 minus 5 minus 3. It is also going to be negative. Don't take this. Then D2A you check. D2A you check. D2A you have to check. D2A delta Q D2A. Same manner, and CV delta T 3 by 2 R delta T. Now when you calculate this, again you will be calculating this way only. Delta T, how will you calculate? So 3 by 2 R will be there, or divided by R you will do. Delta T you will calculate like this. Final will be this 300 into 5 by R minus 100 into 5 by R. Correct? Because this is pressure into volume you have to take. So here pressure into volume 2, here like here 5 are there, here 2 will be there, correct? So here will be 300 into 2 will be there, and this will be 100 into 2. So 300 into 2, 300 into 2 minus 100 into 2. 600 minus 200, 400 by R it will come. This is 400 by R it will come. So this will be how much? 600. 600 will come. Okay. So did I do any mistake here? Calculation. Check 3 into 3, 9, 900, 9 into 5, 40, 500 by 2. 2250, correct only. This is 600. It is coming. So we need to add that, right? Are they asking total heat exchange or only heat absorbed? They are asking heat, total heat supplied to the gas. If they are calculating the only heat absorbed, then this means 2250 plus 600 we have to do. 2250 plus 600, answer should be 2250 plus 600. So 2850 joules should be the answer. But if they are only calculating for the entire cycle, then area you have to calculate. Area will come how much? Check that. This is 200 and this is 3. Then that means 600. Might be they are taking the total area. But this question, I thought it is a good question, but they have not used the proper word. I think here there is, and TA has done mistake in the question. Total heat supplied to the gas, when they say, that means total heat given to the gas. Heat input only you have to calculate. Positive heats only you have to calculate. Not the total heat change you have to calculate. Because there will be some heat release that you should not count. But here they have done the calculation of total heat for the entire cycle, which is just area under this graph. So NTA has confused itself. Okay, then let us move to the next. So in this question, might be then argument will be there. They might give bonus or something like this. Okay, let us move next. Two infinitely long parallel conducting wires A and B carry currents I and 2I respectively in the same directions. Parallel wires are there carrying current I to I. Okay. Wire A has uniform mass per unit length lambda. So these are two infinitely long carry current. So this is I and 2I. Mass per unit length is lambda, lies in the insulated fluid, and The wire B is kept at a height h above the floor. Okay, so one is on the ground, another is above that. The minimum magnitude so that minimum magnitude of h so that wire A does not rise from the floor is minimum height. Okay, so if it is rising because of force only. So force between parallel wires must balance mg. So this is mg and this is the force between parallel wires, which is what? Mu naught I1 I2 by 2 pi d. D is the height h. Okay, this will calculate. Okay, the wire A has uniform. The wire B is kept at B is going to pull it. So B has current I2. B is going to pull this wire, first wire. Okay, lambda. Minimum magnitude of h so that the wire A does not. So this is the force per unit length. Remember, force per unit length it is. Force. This is the formula for force per unit length. So we are taking unit length. So unit length mass is lambda. So lambda into g you have to write. So this mu naught current product of current, so I into 2I by 2 pi h is lambda g over just one formula only. So we need to calculate what minimum magnitude of h we need to calculate. So this 2 will get cancelled. So mu naught I square by pi lambda g. This will be the formula. Mu naught I square by pi lambda g. Option 3. Okay, let us move next. Last question. Consider spring mass simple oscillator in one dimension, the mass of particle m and the spring constant k. At a given instant, the extension of the spring is x meter and the speed of the particle is this. On the x v plane, if the graph of v as a function of x is a circle, then the correct option is. They are saying that the plane of, so how does this x v plane means speed? How does the speed changes? And x is extension. So how does the speed formula remember? Speed is omega root under a square minus x square. I think this is the formula for that, right? That's the formula. They are saying that what they are saying. The given instant extension is x, speed is v. On the xv plane, x and v, we need to make the circle. The graph of v function is circle, then the correct option is. Okay, relation between that we need to know. So omega is what? Okay, let us square this. So v square is equal to omega square a square minus x square. Omega square is k by m, right? Omega square is k by m. This is what we are getting here. Omega square is k by m. K is what? At a given instant x v plane, if the graph of v as a function of x is a circle, then the correct equation. That equation is a circle only, no? Isn't it a circle? It is. Oh, this is not a circle. It will become ellipse. This will become a circle when k by m is 1. If k by m is 1, k by m ratio is 1, then v square is equal to a square minus x square. Then v square plus x square is equal to a square. Okay, that's all. So k by m must be, ratio must be 1, k and m must be equal. Okay, k and m must be equal. This we can take. K by m must be equal. Done. I think we are done with this. I hope you have got this. So this idea is that this question was definitely difficult paper because some of the questions are lengthy. Tricky it was, not that very difficult, it was tricky, it is. And some of the things formula you have to remember. Most of the questions, you as a NEET student, you must remember all the important formulas and tricks. If you do not remember, it will be lengthy to derive and solve that. That is why it is more time taking, otherwise not. For those students who have worked hard and remember all the formulas and shortcuts, and by understanding them, they have done that, it will be easier for them. Otherwise, for most of the students, this will be a tougher side, right? Moderate, it will be for those who have practiced it, right? But those students who have not got that much, efficiency, definitely it's a lengthy and tough paper. So I hope you have got the essence of, the paper, the Re-NEET paper that has happened today, means yesterday, and you can go through that. But some of the questions that NTA has done, that is not proper standard, as you can see, and some of them has glitches, as we discussed that. So those who are writing NEET in the next year, all the best to you, and be in communication, discuss questions. As you know that I am taking free online batches for you. So there are two batches that I have started. One is NEEV 1.0 for grade 11 free batch, and another is for TEJAS 1.0 batch, that is also free. So those who are interested can join my platform, and obviously everything will be free. You have to just enroll in our app, and then we can be in touch, and I will be able to help you for anything, right? Thank you all for your attention.